Alright guys, this is the mix for orbital notation drawing. This is the fun ones with the arrows, so let's get into it. Alright, so remember this is Unit 3. Our goals: write and recognize electron configuration and orbital diagrams and estimate abbreviated ones. So we're mainly focusing on I can complete orbital diagrams, and ideally I can identify an element based on this orbital diagram. And this is actually super easy, but we'll go over that. Okay, so there's 4 rules that kind of guide all of this. The first one is ground state. Most of the time we're talking about ground state is the lowest energy level of an atom. So this is when the electrons are as close to the center of the atom, so close to the lowest level as possible. If they're in anything other than their lowest, that's an excited state. We're not really worried about drawing these in excited state. Just be aware that's what it is. So this is all about drawing in ground state. So then we have 3 rules. We have the Pauli exclusion principle, which there can be a maximum of only 2 electrons in any given orbital, and they have opposite spins. So that basically means for every orbital, every space we have, you have 2 electrons, one up, one down. You cannot have 2 ups. That's a no-no. You cannot have 2 downs. That's a no-no. Okay. Next, we have the Aufbau principle. This is that electrons are added by filling sublevels in a specific order based on increasing energy. So S, P, then D and F. D and F are odd though, and we'll talk about them more in another mix, but it's just the idea like this is you fill 1s before you fill 2s, before you fill 2p, before you fill 3s, before you fill 3p. That's the Aufbau principle. And finally, Hund's rule. Hund's rule is electrons will spread out in a sublevel if possible. So like in the S sublevel, we only have 1 suborbital, but in like P where you have 3, this is where it comes in. I refer to this as the urinal rule. Most male students get this pretty quick. And that is if guys go into the bathroom and there's several spots, they're going to spread out. They're going to leave a space between each spot before they then go back and fill each one in. So, same thing with Hund's rule. We're talking about with electrons, so it's the urinal rule. So if you had 3 spaces, the first electron goes in the first space, the second electron goes in the second space, the third electron goes in the third space. And then, and only then, do you go back and fill. And remember, because of Pauli exclusion principle, if you have an up, then you do a down. By the way, this is how I draw the arrows. It's really fast. It's way faster than trying to draw that. So that's how I'm going to do it throughout this. Alright, so it's pretty straightforward. The orbital diagram for beryllium. So you got to remember that beryllium is element number 4. So that means when we start putting the electrons in, you go 1 up, and this is the s orbital, so you then go 1 down. Then we go to the next energy level, so 2s, or 1s2, 2s2. So we put 2, and that uses all 4 of our electrons, so we're done. So this is the orbital diagram. Remember, this is how we'd write the electron notation for it. The other way that I will often write these is I'll draw them, because your computers don't have these cool little things. I would draw it like this, where this is the 1s, this is the 2s, and then 1 up, 1 down, 1 up, 1 down. So that's beryllium. Easy, let's do another one. So carbon has 6 electrons. So 1, 2, that fills the 1s, 3, 4, that fills the 2s, we have 6, we have 2 more. So the first one goes into the first suborbital of 2p, and then due to Hund's rule they spread out, so the next one then goes right there into the second suborbital. So if we draw it, it would be 1s2, 2s2, 2p2, and I would draw it like this: 1s, 2s, 3 spaces because there's 3 suborbitals, so 2p, and then we put our 1, 2, 3, 4, 5, 6. That would be how you draw it if you're drawing it out on paper and not in the fun little diagram. Let's do another one. I'm hoping this is pretty easy. So nitrogen, nitrogen has got 7 electrons. So same idea: 1s1, 1s2, 2s1, 2s2, and now we have 7. We've used 4, so we have 3. So Hund's rule is we're going to spread out: 1, 2, 3. Boom. And then the electron configuration: 1s2, 2s2, 2p3. And again, I would draw it like this: 1s, 2s, 2p. So 1, 2, 3, 4, 5, 6, 7. Alright, do a little bit. Oxygen. Oxygen's got 8. Same idea. 1, 2, 3, 4, 5, 6, 7. And now, Hund's rule, we've now filled each orbital, so that 8th electron is going to go in and fill that last space. So the full electron configuration, 1s2, 2s2, 2p4. So I would do it like this. There's 1s, 2s, 2p. So 1, 2, 3, 4, 5, 6, 7. And then we go back. We've fulfilled Hund's rule, so we can put a second guy in there. Boom. Okay, so let's do some of these together. So first off, you remember from the previous thing, we call this is the S block, and this is the P block. And S can hold 2 electrons, and P can hold 6, because S has got 1 suborbital, and P has got 6 suborbital, or 3 suborbitals, which can hold 2 electrons each, for a total of 6. Alright, so I've actually found it's easiest for me to write the electron configuration before I draw the orbital diagram. So let's start with that. So magnesium, here's the cool thing. The point of the blocks and why they're useful is if you know where the element is on the periodic table, then you can you know exactly where you're in. So magnesium is right here. So that tells us that magnesium is in the 3s block, and it's the second one in, so that means it's going to end on 3s2. So when we write our configuration, we know we go to 3s2 and then we stop. So it looks like this. You have 1s, and we know that we're filling that, so we put our 2, so 1s2. Now we're into the s block. There's the s block, so it's 1, 2, so 2s2, 1, 2. And we go through the p block, so 1, 2, 3, 2p, and we know we're going through the whole thing, so it's 2p6. When we draw it, it's going to be 1, 2, 3, 4, 5, 6. And now we're on the 3s block, right here, right? So 3s, and it's the second one in there, so 1, 2, 3s2. So there's our electron configuration, and there's our orbital diagram as well. Alright, so sulfur is located is right here. Can't really see that. Right here. So that means it's in the P block. It's in the 3rd row. These are the primary energy levels. So it's in the 3rd row. It's in the P block, and it's 4 spaces over. Okay. So it means it's going to end on 3p4. So we're going to fill. We're going to do our electron configuration until we get to 3p4. So we go 1s. We do all of 1s, right? So 1s2. 2s, so 2s2, so up and then down. Now we go to the 2p, so 2p, and we know it's got 1, 2, 3 spots, and we're going to fill all of it because we keep going. So 1, 2, 3, 4, 5, 6, we're good. And then we're at the s block, so the s, 3s2, we're going to keep going through it, so we're going to put 1, 2, and then we're on our p block, so 3p, and we're going 1, 2, 3, 4, so 1, 2, 3, 4. So 3p4. So there's both the orbital diagram and the electron configuration. Here's the thing. The other thing is, remember, you can check your stuff by what are you drawing here? We're drawing the electrons, right? So when you look at this, it should be straightforward because this is sulfur is atomic number 16, which means it's got 16 protons, which also means it has 16 electrons. So if we did it right by looking at, wow, so looks like a drill line. We count these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. The number of arrows you draw should equal the number of electrons you have because the arrows represent the electrons. I don't know why I put oxygen on here. We're going to do that because I did that in a previous slide. Okay. But remember, oxygen would be right here, so that just tells you it's going to end on 2p4. And if you go back a slide, you can see that we went to 2p4 with that. So, what we should be able to do at this point, you should be able to draw anything, any element between that from the S block up to the row 4, and in the P block up to row 3. What about the rest of the elements, you might ask? There's a whole lot here. Well, that is coming up because now we still have to talk about what we call the D block, and then eventually the F block. And they're a little bit different, so we're going to save those for the next slideshow. Alright, I hope this helps.